Welcome to Skill 4. This is the first page of notes for Skill 4, so please make sure you have your notes folder open and you're ready to add to your guided notes. For Skill 4, we're going to work on the skills of rewriting fractions and whole numbers as equivalent fractions. Basically, we're going to take fractions and whole numbers and look for different ways to write them without changing their value. So to begin with skill 4, we need an important vocabulary term. We're going to grab this term up here at the top. This is the term equivalent fractions. Equivalent fractions are fractions that have the same value or show equal amounts. The big idea here, let me write that neater. The big idea here is that they're two fractions that are equal. You can think of equivalent fractions as cutting up your fractions in a different way. Just like when you order a pizza, they could cut it into different amounts of slices. It doesn't change how much pizza there is in the box, but it does change how big your slice is. So the big idea is just cutting up fractions differently. And so that's over here in our thinking bubble. Can I cut up my fractions differently? So let's look down here at our draw it section. We have the same whole number cut up a bunch of different ways, and we're doing that so that we can show all these equivalent fractions. We have 1/2, 2/4, 3/6, and 4/8. And as you can see, all four of these fractions are equivalent. They're all equal to each other. So let's look up here. I have 1/2, which means I need to shade in one of the two total pieces. So I can shade in one piece here. Oops, let me get a thicker marker. There we go. There we go. All right, so let's shade in 1/2, and I'm going to invite you to do this on your notes as well. And we can show what 1/2 looks like. 1/2, 1/2. Now we know 1/2 is equal to 2/4, so I'm going to come in and shade in 2 of these fourths. This is a different fraction. 2/4 is a different fraction than 1/2, but by looking at the drawings, I can see 1/2 and 2/4 show the same amount. 2/4 are just cut up into smaller pieces, so I get more of them, but it's the same amount colored in. We can keep going over here in our 3/6. There we go. 3/6. Again, it's the same amount. It's cut up differently, but it's still showing the same value. And I can do the same thing over here with 4/8. It is the same value. I didn't make more or less stuff. All I did was cut this one into 4 smaller pieces, 3 pieces, 2 pieces, or 1 piece. But overall, if I was thinking of this like food, like a pan of Rice Krispie treats, you would get the same amount for all 4 fractions. They're just cut up into different sized pieces. That's the big thinking when we talk about equivalent fractions. So we can draw it to show how these fractions are the same value but are cut up differently, and so they're different fractions. Now moving on to the solve it section, I can see now they've given us fractions and they're asking us to rewrite them as an equal or equivalent fraction, but there's no drawing for these ones. For these ones, we need another strategy for creating equivalent fractions, and that strategy is going to be by multiplying. So looking here, I have 3/5, and my job is to think, if I have a fraction cut into fifths, what do I have to do to that 5 to turn it into 10? To turn 5 into 10, I could multiply, oops, To turn 5 into 10, I could multiply by 2. 5 times 2 equals 10. I'm going to write that off to the side. 5 times 2 equals 10. So whatever I do to my denominator, I'm going to do the exact same thing to my numerator. I need to multiply that by 2. Oops. There we go. 3 times 2 is 6. So I've used the multiplication strategy to show that 3/5 is equal to 6/10. Let's try that for another equivalent fraction. I'm still working with 3/5, but now I want to turn it into 15ths. So I have to think, what could I multiply 5 by to turn it into 15ths? I could multiply it by 3. 5 times 3 equals 15. Whatever I do to my denominator, I have to do the same thing to my numerator. So I'm going to multiply that by 3. There we go. 3 times 3 equals 9. So 3/5 is equal to 9/15. Now if you're wondering why this works, let's draw this first one out. I'm going to draw a box, and since I'm working with fifths, I'm going to cut it into 5 pieces. To show 3/5, I'm going to color in 3 of those pieces. Hang on one second, let me try that again. Here's my box. Cut it into fifths. And color in 3 pieces. There we go. So if I have my 3/5, when I multiplied it by 2, back here in this first problem, when I multiplied it by 2, what I really did is I took each piece and I just cut it into 2 pieces. In that way, I can see whether I write my fraction as 3/5 or I write it as 1, 2, 3, 4, 5, 6, 6 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. All I did was take the same thing and cut it up into different ways. When I multiplied my denominator times 2 and my numerator times 2, all I did was take my existing fraction and cut each of those pieces into 2 pieces. The same thing goes for this fraction. When I multiplied by 3, it would be like if I took my 3/5 and instead of cutting them into 2 pieces, I had cut it into 3 pieces. The cool thing about this is there are an infinite number of ways you could cut up your fraction. So let's keep working with this 3/5 fraction and find other ways to make equivalent fractions. For this one, I started with fifths, and I'm trying to turn them into 30ths. 5 times 6 equals 30. Whatever I do to my denominator, I need to do to my numerator. So I can multiply my numerator times 6. 3 times 6 is 18. And let's keep going. Now I'm working with 3/5 and I'm trying to turn it into 50ths. I'm going to cut up each piece until I have 50 pieces total. To turn 5 into 50, I had to multiply by 10. So I'm going to do the same exact thing with my numerator. I'm going to multiply my numerator times 10. 3 times 10 is 30. So by looking at this, I can see that when I start with 3/5, I could rewrite it as a lot of different equivalent fractions. I could rewrite it as 6/10, 9/15, 18/30, or 30/50. These are all ways I could rewrite this as an equivalent fraction. If you're feeling a little stuck, the big idea is to build an equivalent fraction. The numerator and denominator are multiplied by the same factor. So when I multiplied my numerator and denominator both by 2, that was the factor I used for that one. For this problem, we multiplied them both by 3, so that's the factor we multiplied the numerator and the denominator by. For this one, we multiplied them by a factor of 6, and for the last one, we multiplied by a factor of 10. This is the mathematical way to solve this kind of problem. So now we are here at the try it problems. For the try it problems, you have a couple different options. If you're feeling confident in this skill, you're invited to pause the video, solve them on your own, and then follow along to check your work, making any corrections as needed. If you're not feeling very confident yet, continue to leave the video rolling and work along with me. At any point, if you feel ready to try some on your own, you can always pause the video and start trying independently then and check your work. I'm going to start here with the first problem. We have 2/3 and we want to rewrite it with a denominator of 12. Basically, we are taking the number 2/3. Oops, there we go. No, that's not what I wanted. There we go. We're going to take the number 2/3 and we want to rewrite it as 12ths. The question we have to ask ourselves is, what do I need to do? Oops, let me use a skinnier marker. What do we need to do to turn thirds into 12ths? Well, thinking about my multiplication, I know that 3 times 4 equals 12. So to do that on my drawing, I need to cut each piece into 4 pieces. So going the other way, I'm going to cut it in half and then into 4ths. I took my 2/3 and I cut it up differently. Now I have 12 total pieces, and then I can use my strategy of multiplying my numerator by the same factor as my denominator, which was 4, to figure out how many pieces I should have colored in. 2 times 4 is 8. And when I look back at my drawing, I can see 1, 2, oops, let me get a better color. 1, 2, 3, 4, 5, 6, 7, 8 pieces are now colored in. We turned 2/3 into 8/12. Let's keep going. Now I'm going to look at this one here where we have 7/8, and we need to rewrite it as an equivalent fraction using the denominator 40. Using my multiplication facts, I know that 8 times 5 equals 40. To make the fraction equivalent, I need to multiply my numerator by the same factor. I need to multiply it by 5. 7 times 5 is 35. 7/8 is equal to 35/40. Let's keep going. Now I have some 7ths are equal to 47ths. This one I'm going the opposite direction. I've got 70 and I want to turn it into 7. Well, I know that 7 times 10 is 70. So if I wanted to go that way, 7 times 10 is 70. To go backwards, I'm going to have to divide by 10. And then I can do the same thing to my numerator. I started with 40. I want to divide by 10. 40 divided by 10 is 4. And finally, we have 2/3 are equivalent to some 12ths. Hey, wait a second. That's one of our starter problems. You get an easy problem. All right, we know that we had to multiply by 4. 3 times 4 is 12. Whatever we do to our denominator, we have to do to our numerator. So I'm going to again multiply my numerator by 4. 2 times 4 is 8. The last question is a little bit different, but it's asking us to use the same strategies. It says, write 3 different equivalent fractions for 1/8. So I can write 1/8, and then I need to think of fractions that it's equivalent to. Well, I could try multiplying it, both my numerator and my denominator, by 2. 1/8 could easily become, if I multiplied by 2, 2, 8 times 2 is 16. I could rewrite it as 2/16. I could start by multiplying my 1/8 by 3. 1 times 3 is 3. 8 times 3 is 24. Then I could multiply my numerator and my denominator each by 3. Oh, I'm sorry, we already did 3. By 4. 1 times 4 is 4. 8 times 4 is 32. Now there are many different equivalent fractions you could have written. You don't have to just use those ones. For instance, you could have multiplied them by 10 and gotten 10/80ths. Or you could have multiplied them by 100 and gotten 100/800ths. There are an endless number of equivalent fractions you could make. All right, your job now is to go back through your notes and make sure you have completely filled them out. If there's any spot where you were paying attention to the video and you missed taking the notes, go back to that part of the video and get your notes completed. When you are finished, you can move on to the second video for the lesson 4 notes.